might say, oh, I didn't quite catch that formula, you can always watch the video and you can see the formula on the video. So it's all going now. So just a little bit of PowerPoint and then we'll get right to the Excel. So first off, there we are. So we need to talk just briefly about the t-distribution. What is the guy's name? Oh, see, I can't even remember the guy's name. So there was a guy back around the turn of the century who was working for Guinness Brewing Company in Dublin, Ireland. And he was in charge of making sure that the beer that Guinness produced was as the best quality possible. And he was using statistics to do this. And so he was using normal distributions, but he found that the normal distribution didn't match his data as well as he would like. The reason was that his data was from very small sample sizes. He had sample sizes of sometimes as small as 3 or 4 or 5, which is terrible. Terrible to have such a small sample size, but apparently because of the manufacturing process, they could only get such small samples, and that's the way it worked. So he studied what was called the t-distribution. And he found that the t-distribution was a much better match for the data that he was using, these small sample size data sets. And so he ended up publishing a paper in various statistical journals about his work, but he was scared of retribution from his bosses at Guinness Brewing Company, and so he ended up publishing this paper under the pseudonym Student. And I should know his name. I can sort of picture it, but I can't say it, so I'll just not try. But if you Google Student's t-distribution, you'll get this little story, anecdote, as well as his actual name. So he published around 1900 or so about how he could use these small batch distributions using this t-distribution. And so since he published under the name Student, this is often called the student's t-distribution. Not because maybe because you're students, maybe he thought students would use it, but it's because of this guy's pseudonym. So this t-distribution is bell-shaped and symmetric around the mean, just like the normal distribution. It looks, for all intents and purposes, like a normal distribution. And I don't have any of my nice printed normal distributions here because I've given them all back, but you have them on your exams. You know the normal distribution. The difference is that it's a little bit fatter and like it's squished down a little bit. So it's as if you had the normal distribution made out of like a water balloon in the shape of a normal distribution, and you just push down on the top a little bit so it's squished out a bit on the sides. So it looks sort of like a shorter, fatter version of the normal distribution. This is not that exciting, but the variance ends up being bigger than 0 or bigger than 1 because it's squished out. The degrees of freedom are related to the sample size. So when we get to degrees of freedom, it just means that the larger your sample size, the less you're squishing down the normal distribution. So if you can imagine a big normal distribution here, if I have a small sample size, I'm going to squish this down really far and squish it out. So it kind of makes your data set sort of squished out further. And then when you have a larger sample size, there's less variability, and it kind of pulls everything back towards a normal distribution. So all that is to say that when we do any statistics, instead of using the normal distribution, we use this related t-distribution. It looks very much like a normal distribution, and it acts like a normal distribution, but we have to deal with what's called degrees of freedom, and degrees of freedom are related to the sample size. In particular, the degrees of freedom is the sample size minus 1. There are reasons for this philosophically, but we don't have to go into that. You just have to remember that the degrees of freedom are 1 less than the sample size. We'll use this numerous times today, and we'll code it into Excel. Okay, next thing. So, look, so scary, isn't it? So here is what your confidence interval is going to look like. I know all of these words. Let's go through. I should have had it build a little bit slower. So we start off with, let's say we want to find a 95% confidence interval. 95% means alpha is 0.05, 5%. So alpha is always the stuff outside the confidence interval. I showed you that picture last time. And so that's the deal there is you take the confidence interval percentage, subtract it from 100%, and you get alpha. So alpha is the opposite of how confident you are, and that's why this is written this way. X bar is your sample mean. This t here, we'll get to this in a bit, it's going to be the critical number for the t distribution. So it's how far out. Like with your confidence intervals for normal distribution, you would expect to go, say, 2 standard deviations out to get a 95% confidence interval, because the empirical rule says that 95% is 2 standard deviations. So this just tells you how far you need to go to get whatever confidence level you need to be. Anyway, we're gonna put all this in Excel with something that looks similar to this eventually, but we're also going to use a special tool called confidence.t. So Excel has most of this, not all of it, but most of it built in to its coding. And I believe this works even with your iPad, which iPad man is not here, and I believe it'll work with the online version. So if you didn't want to use a real computer, you can use a fake computer with online access to the online version of Excel. Let's see, oh yeah, here it is. Okay, so there's a lot of stuff. When you go to Newton, you will find these sorts of how-tos. If you forget, you can follow the how-tos. It will show you, and look, it even has that formula down here. Not to worry, we will put the formula into Excel. Blah, 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 blah. So let's actually do this with a data set. So here's what I'm going to do. I've got a new version of Excel, new open here. Let's see. I'll make this big for a sec. Oh, wait, where's my mouse? There it is. Okay, so it's giant. Can I make it small? Oh, I can make it small and big. Okay, so just so you can see where I'm starting, brand new open thing, and you've got the nothing going on down here. What I encourage you to do right now with a clean version of Excel, clean spreadsheet, go up to File, save it somewhere where you know where it is. I don't care where you save it. You want to save it to OneDrive, great, just as long as you can retrieve it. I'm going to save mine to my statistics folder, and I'm going to name it something special because this is like gold. You're not going to lose this. So this is, I'm going to call this confidence interval gold. You don't want to lose this. It's, you should think of this like gold. It's so precious. When we get done with this, you're going to use it for your homework, and it will be super helpful. So confidence interval gold, stick it somewhere where you know where it is. Mine is in my, spring? No, I want it to be in my fall. Hold on a minute. Can I put this into fall? Let's see. Oh, here, this is annoying. Now I can't see. Confidence interval, I want to put it in fall 2024. There it is. Okay, so, but you put it somewhere where you know where it is. And if you don't know how to use your computer, ask your neighbor. They'll help you figure out. But put it somewhere where you know where it is, because you're going to want to be able to use this over and over again. Okay, so now let's put this together. Hold on a sec. I have a cheat sheet that I need to look at so that I don't get lost. There we go. And just a sec there. Okay, so we're going to start off by setting up the, do I have this right? Yes. By setting up the whole spreadsheet so that we can use it for this problem. I'll go back to the problem momentarily, but here, let me go back to the problem just for briefly, and you'll notice back here that there are a bunch of things that we're going to want to include on our spreadsheet. For example, we're going to want to know the sample mean. We're going to want to know the confidence level, alpha maybe. So there's a bunch of stuff that we're going to include on our spreadsheet. So all of those letters, I will put them in words though. So up here in A1, I'm going to call that the sample mean. Now, just a word of warning. If you follow along with Newton. The Newton version of doing this, they put all of the words in column B and all of the numbers in column A. I don't know why. I kind of think you put the words here and you say, this is right here, you know, but whatever. It's fine. It's just, they have very similar formulas that they use. I'm going to move this over so you can see all of the words. Next down is the sample standard deviation. And I'll put those numbers here, by the way. I'm going to move this over just a bit more to accommodate all of my words. The next, I'm going to have the sample size. These are all things that I'm going to have to input to be able to compute a confidence interval. Finally, the confidence level. So this is like well, I won't put a percent there. So it's like a 95% confidence interval, that sort of thing. Now, in order to highlight, these are the numbers that you're going to input. I'm just going to highlight this and make it, let's see, I'll make it green. Green is for go. If you are color challenged in terms of your ability to see color, you can highlight this, do whatever it takes to make it so that you can see what it is that you're going to be inputting. So these are, you can mess with these. When we get below this, maybe I should put a line there. Let's actually do that. Let's see, sorry, I have to keep looking back and forth. Let's do this. Okay, now I can see it on both screens. Maybe I'll put a line there just to indicate that that's, oh wait, did I put that in the right place? Ooh, my line's not in the right place. My line should be under this. Give me a sec here. I want it to be really thick. There we go. Thick bottom border. So you see how there's a nice line there. So everything above the line you can mess with. Below the line, we're going to have formulas. That's where the gold is. You don't want to mess with the stuff under the line. Okay, so, oh, and if you get stuck anywhere, that's when you need to call me out and say, stop. So your computer is not operational now. We got to get you a new computer. I'm going to dig through my stuff. I might have one better for you. I'll let you know. Yeah, so you'll need to make one of these at some point. Or beg someone to send it to you. Make a friend. There's friends. Okay, but anyway, getting back here. Yeah, so that's another thing is if you get stuck and you're too embarrassed, don't be embarrassed because there's 3 other people who are stuck as well. But if you get stuck, you can always ask your friend to email you the file when it's done. So that's another option. But let's go through this. So next, what do we got to do here? We need to type in, let's see, I got to get my stuff here. Over here, I've got alpha. So alpha we're going to compute. In fact, let's go back to this problem that we're going to be doing so that we can get started on inputting these numbers. It says that we are to construct a 99% confidence interval. 99%. That is the confidence level. So over here on my spreadsheet, under confidence level, I'm going to put 99%. You could also put 0.99. I don't care how you input it, but we'll be consistent. So 99% is fine. And then down here, alpha is 100% minus this. You could input this a bunch of different ways. I'm just going to write equals 1 minus that number there. It should show up as 1% because 100% is 1. So that's how I've done that. That gives me my alpha level. Once I've got that formula working, I'm not going to touch it ever again the rest of the semester, by the way. So far, so good? Okay, we've got alpha. Next, you know what? As long as we've got all the data up here, let's go ahead and compute the mean and standard deviation of these data. Fortunately for you, when you get to Newton, you can copy the entire data set. You won't have to type it in. But for us, unfortunately, I'm going to have to type these data in. So over here, where's my thing? Here it is. Here. So over here, what I'll do is I'll just have a column of data. So I'll just say, hey, this is my data. There we go. So just put it somewhere off to the side because it's not part of this. It's not the important stuff. The important stuff is this. This is just whatever problem you're working on, and you could even have that somewhere else in a different spreadsheet. So my data is, let's see, I got to put this up here. How am I going to do this? I need to be able to see both. Hold on a second. I'll do this. There we go. Okay, bear with me for just a minute while I type. So the data are these numbers, 4, 78, all kind of those numbers in there, 38, 45, 59, 40, 72, and 62. Okay, I think I got all 10 of them. Once you get them, I suppose, let's see, we can double check. Let's do this, mean and standard deviation. Let's see, here, I'll make this big again. Now that I've got all my data, you can see it here. Yeah, you can see them all. I know they're smaller now, but you can still see them if you haven't got them all in there. So the mean is equal to average of all of these numbers. So mean should be 60.2. If your mean is different than 60.2, one of two things is happening. Either I mistyped a number or you did. So I'd be curious, get some independent confirmation that my number is correct. While you're doing that, I'm also going to do the standard deviation equals STDEV dot S. So this is the sample standard deviation because this is a sample. Always going to be S. And then highlight your data, close parenthesis, and it should be 14.13 if I've typed my data correct. Now, if I haven't, if your numbers are different from mine, let me know because it'll help me to double check. So any complaints? My numbers look okay? Okay, some of you are nodding. Thank you for giving me that confirmation. Okay, so we've got our numbers. Let's go back here and we can type them in now. Let's see, sample mean is 60.2. Sample standard deviation is 14.1327. So those numbers, notice the things in green above the bar, that's the stuff that you will change for each of the problems you do. So sample size. Sample size, there were 10 numbers over there. You can count them on your fingers. You could use the count function, but that's going to be 10. So whatever the sample size is for your particular problem. All right, we're getting close, amazingly. So what's next? Give me a sec here, I'll pull this up. Okay, next thing that we're going to use is the margin of error. I've got my notes here. That's the only reason why I'm switching back and forth. Okay, so the margin of error, I'm going to put down here, margin of error. And so that is going to, did I type that? Yes, I did. Sorry, I'm looking at my notes, not the second screen. Okay, so this is equal to confidence T of, now we have to be careful. We're going to use alpha first. So alpha is that 1%. So that's the cell right above that, which I think is B5. Yeah, B5. And then the next thing we need is the standard deviation. And the standard deviation is up here. And then finally, the sample size, in close parentheses. Now, if your version of Excel does not have confidence.t, let me know. I believe that for sure if you have a Windows computer, you have confidence.t. And I think the Macintoshes do. Do the any Mac people, you've got it? Okay, good. Do you have it? Okay, good. Because if you don't, there's a workaround. I'd rather not do the workaround. So the only other person is the iPad guy, and we'll see if he has it when he complains after watching the video. Okay, so there's confidence.t. Now, what does confidence.t do? I know, it doesn't look like it did much at all. Confidence.t does this for you. Let me back up for a sec. It does this right there, this stuff right here. It does all of that in one fell swoop. So it takes that standard deviation, it takes that sample size, and it computes the value of t star, which is either, it's probably around 2. Wait, 99, it's probably around 3. Yeah. You got help? Okay, now let's take a peek. But anyway, that's all that confidence t does, is all that mess. What's going on? Never mind. You just have, yeah, you love your commas. Yeah, it seems like some programming languages, you can put a comma at the end and it's not a big deal, but you can't use your extra comma here. Okay, so anyway, that's all confidence t does, is it computes that value for us, which happens to be the margin of error. So now that we've got the margin of error, let's get our lower confidence limit. And the lower confidence limit is the middle, the mean, minus the confidence, or the margin of error. So that's going to equal the mean, that's that number up there, minus the margin of error. And actually do it using the cell references, so equals B1 minus B6, because you want to be able to reuse this, and we'll see how we reuse it in a bit. And then the upper confidence limit, upper confidence limit is the other one. You take the mean, so that's going to be B1 plus B6. And there it is. We're almost done. So now you've got all the numbers you need. I'm going to highlight this stuff. Where is it? Here it is. There, there. And I'm gonna color this. Just a sec. This is annoying me. Try again. There. Okay, so I'm going to color this like red. Red is a little dark, isn't it? Well, red's fine. Red to sort of indicate, no, don't do it. Or maybe I could do yellow. Yellow might be like caution. Don't touch those. Those you shouldn't mess with. Yeah, yellow might be better because you can actually see the numbers now. So yeah, make those yellow, or if you're color challenged, you can pick whatever color you, or shading. I think they have different shading ways you can shade things. But anyway, so those, you can mess with those. Don't touch those. Okay, last thing that we need to do, and this is for me, it is not for, Okay, let's focus on Excel for now, and then we'll deal with what I want on Wednesday if we don't have time today. So we're done. This is the confidence interval right there. Those two numbers give you the lower and upper confidence limit. Let me show you how this works with Newton, and then we have to do a second tab. Give me a sec here. Let's see, view. So let me pull up the homework for next time. There we go. Put this over here. Hold on a sec. There. Okay. Confidence interval. Okay. So this is the sort of thing that you're going to have to do on your homework. Is you've got a problem that involves a confidence interval for a mean, and it says, oh, wait a minute. That I shouldn't have here. Just a minute. Sorry. This is not right. Hold on a sec. If you've okay, no one has started this. Thank goodness. Let me edit this because they won't let me edit. Standard deviation. Just a minute. Edit this down. Delete these. I'm just going to delete the assignment. Sorry. I picked the wrong topic. Let me close this. This will just take a sec. Okay, sorry about this. I'll make a new assignment. That's what I'll do. Okay, give me a sec. This will just take a sec. Cancel that. Add. Okay, so you'll see two. I'll delete the wrong one eventually, but let me add the right one. Confidence intervals. Okay, just a sec. Confidence interval for population mean with the Excel. There it is. Okay, I got t-score. Do I care? No, I don't. We'll just do that. Sorry. And then population proportion. Sorry, I did this before, and apparently I chose the wrong thing. Confidence level. Okay, we'll do those. We'll do those. Next. Correct version. Let me just change the date. Okay, I'm glad I looked at that. Create. Okay, so here's so it's labeled correct version before. Well, here I'll just delete this now since I'm sitting up here. Delete, gone. Okay, the bad one is gone. The good one is still there. So let me preview. Sorry about the delay there. Okay, this should be better. Here we are. Pull this over. And so yeah, this is correct. Yeah, it's just a slight difference in the formulas, and yeah, you would have been losing your mind if I left it that way. Okay, so here's the sort of question you're going to have. It says, and I know you can't see it very well. Let me zoom in a little bit, but it can only zoom in so much and not. There it is. Okay, so suppose the number of dollars spent per week on groceries is normally distributed with unknown mean and standard deviation. Random sample of 18 grocery bills. So immediately I go over here and I change my sample size to 18 grocery bills. Whoops, I pressed help by mistake. Try again. Let me zoom out a bit. There you go. Okay, so that should be 18. Okay, that's better. It does the sample mean is 103. Let's go up here. Sample mean 103. And the standard deviation for the sample is $10. So we have that for sample standard deviation. You just have to sort out what the numbers mean, plug them into your confidence interval gold. That's why I call this the gold. And then it says it wants to find the margin of error for a 98% confidence interval. So we go down here, change this to 98%. And then, like magic, you have the margin of error perfectly done, and you can type it in. So that's all you got to do. Margin of error is that number there, 6.05, 0321. Does it mark you wrong if you have too many digits? Oh, no, it doesn't. Good. So you can always just copy directly from here to here. So there will be other questions like what is the confidence interval and so forth. They might give you data. If you have a data set, just go ahead and compute the margin of error or the mean and standard deviation, and you can do that. Okay, we have to move on though. So the next thing that we need to deal with is confidence intervals for proportion. Let's see, blah, blah, blah. There it is. So confidence intervals for proportion. These are a little bit more involved, a little bit more complicated, but I think we have enough time to put this together into our spreadsheet. So let's just go over the basics first of all. The first thing is that when you get your sample, we're going to use this symbol. I think I had a prime before. I forget. It seems like Newton toggles back and forth. If you see a P with anything up here, a prime or a hat, whatever it is, it's the sample proportion. So it's the number of successes over the total number of observations gives you the proportion. This is, I mean, 7th grade stuff. You know what a proportion or a percentage is. So we'll go down, and here is the margin of error. So the margin of error has this complicated formula, but we will work it out together. Don't worry. First off, this Z of alpha over 2 just tells you how far from the middle you're going to be, and it's based on alpha. That's your confidence level, and we'll put this all in Excel. Don't worry. And then here's this complicated formula, which is the standard deviation for the binomial distribution. So that's what this is. So that's going to be the margin of error. And then once you have that, this is going to be your confidence interval. So I know it looks complicated, but it's not going to be too bad once we get it typed in. So let's go ahead. Oh, here, let's get an example. So, there's, well, we'll go through, there's you'll see all of this in Newton so that you can use it if you need it later. But this is the sort of thing you're going to see as the thing that you're going to have to be doing is you'll have just three numbers to input. One of them is the number that said yes or they voted, and then the total sample size, and then the confidence level. So let's go ahead and we're going to set up another spreadsheet. Well, actually, it's the same spreadsheet. It's just another tab. So hopefully you know how to do this. In fact, what I would suggest you do is I would suggest you, that you rename the first tab. So rename that thing. And I'm going to name that means. Confidence interval, just mean, I guess, is fine. It's you already know this is the confidence interval spreadsheet. So that's what that one is. And then get a new tab by pressing this little plus down here. And we're going to rename that. So we're going to call that proportion. So you can sort these out. Those are the only things we're going to have to do with confidence intervals. So if you have a mean, you'll go to the mean. If you have a proportion, you'll go over here to proportions. Okay, let me get rid of the zoom for a sec. Here we go. And let's zoom in like this. Yeah, it's as big as it'll get. Okay, let me get my cheat sheet so that I can see what I'm doing. I want to make sure that I get it, make it look good. Okay, as before, we're going to have a bunch of words in column A. And I think Newton actually has their words or symbols in column A for, I don't know why they have the words in column B for the other one. So first of all, number of successes, you know, it'll help me if I move this over just slightly. Let's do this. And there. Because I have my notes covering up part of the screen. So I know you can still see what we're doing. Okay, so we're going to put X here. This is X. Maybe I'll write it as a big X. This is the number of successes. So that's what that represents. And back here, now we're going to have to keep toggling back and forth, aren't we? Oh, do we have to? Hold on a minute. Yeah, we do. There. So the number of successes was 348. 348 people said they had voted for a write-in candidate in this particular election. So number of successes, I'll put 348. Next thing I'm going to have here is in, and that is, of course, the sample size. And the sample size back here is 6,854. So 6,854 people were asked. Oh, this isn't as big as it could get. Oh, no, it is. It's as big as it'll get. Yeah. Oh, well. Doing the best I can. Okay, next we're going to put our confidence level, very similar. Confidence level. So how confident do you want to be? And back there, let me check. I think it said 95%. Yes, 95%. So I'll type that in just like I did on the other one. Okay, at this point, I'm going to put a little bar here, and I'm going to highlight because those are the only numbers that you're going to change when you try a new problem. So I'm going to highlight this with whatever color I feel like would best indicate that. I'm going to use green, but like I said, you can choose whatever color you want to indicate those are good to change. Use caution below here. Now there's going to be it's going to be a little bit more stuff to have to compute here, but bear with me. So we have alpha, alpha, if I can spell correctly, which is going to be 1 minus the confidence level. That's easy, just like the last time we did alpha. P hat, which I'll write like this because I know it looked like fat, but whatever. It's P hat. It's the P with the funky thing over it because I don't want to have to deal with the symbols. And that is equal to the proportion from the sample. So that's equal to the number of successes divided by the number in the sample. So B1 divided by B2, if you've got yours laid out just like mine, but if you have yours in different positions, it's just the proportion in the sample. So far, so good. Next, we need to do Z of alpha over 2. So this one's a little bit confusing. So what this refers to is this refers to your normal curve. Do I have a picture somewhere? Well, I don't have my iPad hooked up. But the normal curve, it's the cutoff. It's how far over you're going to get, in terms of standard deviations, how far over you're getting to get 95%. So in terms of 95%, the empirical rule would say 2 standard deviations, right? 2 standard deviations, that's approximate. The exact number is actually 1.96. So let's get that Z of alpha over 2 using Excel. Fortunately for us, there's a nice, easy way to do this. Sorry, I've got my cheat sheet here. Why did I do that? Just a minute. Make this smaller. Yeah, I just need to be able to see my notes. And okay, so my cheat sheet looks good. So over here, Z of alpha over 2, here's the formula that you're going to use. You use equals norm dot S dot INV of 1 minus alpha over 2. So I go up here to alpha divided by 2. I know that looks complicated. Let me make that a little bit better to see. There. Okay, so essentially what you're doing here is you're saying, where is the cutoff so that I just have 2.5% to the left? I should draw this. I should draw it. I've got to get my thing hooked up for my next class anyway. So just a minute and I will draw. And, well, maybe I'll draw at the end because this is, yeah, that's going to take too long. Okay, I'll draw it at the end maybe if we have time. I want to make sure we get all this in. We're almost done though. Now that we've got that done, get my notes, scroll down my notes here. There we go. Oh, wrong thing. There we go. Okay, so next thing I'm going to use is I'm going to compute what is called the standard error. I know so much. Okay, let's type all the stuff so you know we're almost done. Margin of error, and then the lower confidence limit, and oops, confidence. I spell it correctly. Let me see if I can fix that. Confidence. Does that look better? And then the next one is the upper confidence limit. So let's see. Upper. So there, now we'll be done. Once we get those 4 things in. So standard error is that standard deviation for the binomial distribution. So this is going to equal, it's a little bit complicated, so stay with me here. We're going to do the square root, so squirt in parentheses. You're going to need 2 sets of parentheses. Open parenthesis 1, and then a second open parenthesis. Excel handily colors them different colors so that you can see you have two different. Then we're going to do, I'm going to use the formula. I had it up on the screen before. It's 1 minus p hat. P hat is this number here, times p hat. Oops, sorry, I shouldn't have closed the parentheses. 1 minus p hat. Yeah, oh, yeah, whatever. And then divided by the sample size. So I need to go find the sample size. It's up here somewhere. It's B2. Okay, now I can close parentheses. There. So make sure yours looks just like this. Let me get the number. I'll put the formula back up momentarily. The number you're looking for is really small, 0.00265. 0.00265. So here it is. So if you don't get 0.00265, you probably typed something wrong here. Pay special attention to the parentheses and each of these, and make sure it refers to the numbers if yours are in a different place on your spreadsheet. I'll pause and make sure that you're all okay. Maybe I'll connect this while we're doing that. Good. Oops. That's good. Okay. Okay, so no one's complaining, or maybe you're complaining to your neighbor, which is fine. Here's my, um, I'll just put that up there for now. I'll pull it back. Okay, so 0.00205. So that's like your standard deviation, and we want to go this many. Notice it's almost 2. So that's what the empirical rule says, use 2. This is the exact value, though. Empirical rule is an approximation of reality. Here's reality. It's about 1.96, a little bit more or less. But that's what we're going to do. So here, the margin of error is going to equal the z of alpha over 2 times the standard error. So you should get 0.0052. And then once you have that, your confidence limits should be pretty straightforward. I'll show you what they are. So let me go ahead and finish this, and then you can tell me what you need help with if you need help. So the lower confidence limit is equal to p hat, that's like the statistic, the point estimate, minus the margin of error. And then the upper confidence limit is p hat plus the margin of error. So that's what it should look like. So let me know where you need help still. If you need me to click on anything, or maybe you just need your neighbor to help you out. Either way, I can show you the formula. Like if you want the formula for lower confidence limit, there's my formula.
Can I see the margin of error one?
Margin of error is this one right here. So it's just standard error times d of alpha over 2. Any other requests, special requests? Okay, I'm drawing a little normal curve here. So here's sort of what's going on in the background, at least mathematically. You have this normal distribution, which is an approximation for a binomial distribution. You don't have to worry about all that. But this is where the point estimate will be. This is p hat. It's in the middle, and then the z of alpha over 2 tells you how many standard deviations to go across. So z of alpha over 2 times the standard deviation or the standard error. I'll just call that sigma for now. That's how far you go, and you'll have 95% in the middle here. Now, just the reason I want to put this up here is because the empirical rule said about 95% would be within 2 standard deviations, but if you want to be precise, 95% is actually 1.96 standard deviations on either side of the mean. So that's the precise number, but the empirical rule is it's fine because you're just approximating sometimes. So that's kind of what's happening. There's my numbers. Any other people need help with these? Now, once you get to your homework, let me see, where'd my homework go? Just a minute. I'll get the homework in a minute. Once I find it. Oh, there it is. Okay, so here's my homework. I need to make it big, apparently. Oh, it's gone. Where'd it go? Huh. It just disappeared. It's so weird. It's like invisible, right? I'll just shut it down and try again. Let me try again. Let's see, preview as a student. Okay, this is better. Move this over, stick it up there. That's better. Okay. Population mean. Let's switch to population proportion there, just to show you the types of problems that you're going to have. So notice that in this problem, it says that Rosetta wants to estimate the percentage of people who rent their home. She surveys 250 individuals, sample size, and finds that 48, that's X, rent their home. So we want to set up a 90% confidence interval for this mean. So what we'll do is we'll do it over here. And we had 48 for X and 250 for N. And this is a 90% confidence interval. And you're done. Let me highlight these. And I think we have a minute we can, or a few minutes, we can actually do the words, which is what I really want to do. What did I do? Yellow? Yellow. We'll do yellow. So yellow, be cautious. Don't mess with that if you don't have to. But here's my confidence interval, 0.15, 0.23. So here's what I wanted to show you about that. Let's see, where's my... See if I can put all of this on the screen at the same time. It would be so exciting for me. I'll bet I can. Hold on a minute. Let's do this and this. And then I can move this over. Maybe just make it smaller. There, that's better. Okay. So I will write this down and I will also type it. And I will be using this language every single time we do a confidence interval. And when you do it for me on a quiz or a test, I'm going to expect you to do this. So it's very simple. What you're going to say is you're going to say this. I am blank % confident that the true blank is between blank and blank. Okay, let's fill in the blanks. First of all, 90% confident is what I am for this one. 90%. That the true, what is the true what? Let me go back here. It's whatever we're measuring. So on this one, it is the percentage of people who rent their home. Percentage of people who rent their home. This is for everyone, not just the people in the sample. It's the percentage of all people who rent their home. So that the true percentage of people who rent their home. And it's a bit annoying that you have to write all these words, and this is a math class, but we want to learn how to communicate effectively with our numbers. So that's why I do this. And then finally, is between what? Lower confidence limit first. Don't put 23 first. Put 15.1% and 23.9%. That is a beautiful written confidence interval. I'm going to type that in. You should as well. Somewhere down here maybe. Where is my thing? There it is. So just a sec. So here it is in written words. I am 90%, just so that you have, 90% confident that the true percent of people who rent their home is between 15.1% and 23.9%. So like I said, you aren't going to have to do that for Newton, but you're going to have to do it for me, so you might as well get used to it. So we will practice this more. By the way, you could do the same thing for the first problem that we did. Whatever problem that was, it was an average. For the average problem, let me just erase this and this. Whoops. So if I get rid of all of this, you could modify this to be an average. So I am whatever it was, 99%, that the true average cost or whatever it is of blah, blah, blah is between, $57 and $62. But so I'm just taking that structure. The red stuff is going to always be there, and you're just going to insert the other stuff. We'll practice this more next time because we won't be using Excel on Wednesday. We'll just be doing it on paper. So I think that's it. Stick around if you have any questions or concerns. Otherwise, Hope you have a great Monday.